So today we want to look at the last part of our mock past questions. And under this, the last question in our last mock past question is question 15. So let's begin with 15A. The 15A question states that, what do you understand by the following? We have got 1, doping. We have got 2, nuclear reactor. We have got 3, radioisotopes. We have got 4, state the function of the following materials in a nuclear reactor. That is D2O, heavy water, and beta, cadmium rod. So let's start with A1. What is doping? Doping, as it is used in semiconductor, is the addition of impurities to a pure semiconductor. The addition of impurities or impure materials to a pure semiconductor in order to improve its conductivity and some other properties. We have got 2. What is nuclear reactor? Nuclear reactor is a system in which a controllable nuclear chain reaction is used to generate nuclear energy. Nuclear reactor is a system in which a controllable nuclear chain reaction is used to generate nuclear energy. Radioisotopes. Radioisotopes are unstable nuclides of the same element, having the same atomic number but different mass number, d to the difference in neutron number. I repeat, the isotopes are unstable nuclides having the same 2 unstable nuclides having the same of the same element, having the same atomic number but different mass number, d to the difference in their neutron number. State the function of the following materials in a nuclear reactor. The first one here is D2O. Now, they can use D2O or graphite. Both D2O, heavy water, and graphite perform or have the same function. And what's the function of heavy water and graphite? They slow down fast-moving neutrons. While the cadmium rod function in the nuclear reactor as it absorbs the excess neutrons without undergoing additional reaction. It absorbs excess neutrons without undergoing or causing any additional reaction. So let's look at question B1. Question 15B1. State at least 2 wave properties and 2 particle properties of light. 2 wave properties and 2 particle properties of light. So for wave properties, for light to have wave properties, it must satisfy the condition of reflection, it must be able to refract, it must be able to diffract, interfere, and the plane polarize. So these are the wave properties that light must be able to what? Must be able to undergo before it must possess wave properties. That is the reflection, refraction, diffraction, interference, and polarization. While the particle properties are the Compton effect, Thomson effect, black body radiation, etc. Thomson effect, Compton effect, black body radiation, etc. So let's look at question B15B2. A particle of mass 5.6 exponential minus 23 kg moves with the velocity of 1.0 exponential 6 meter per second. Calculate its de Broglie wavelength. Now, how do you calculate the Broglie wavelength? We have what we call the Broglie equation, which is P equal h over lambda, which is P equal h over lambda. The de Broglie wave equation is P equal h over lambda, where P is momentum, h is the Planck constant, and lambda is the de Broglie wavelength. But P made the momentum equal mass times velocity. So from the parameters we are given in the equation, we now substitute. I have mv equal h over lambda. So that my lambda will now be h over nv. My lambda equals to h over nv. And what is A, which is Planck constant? That is 6.63 exponential minus 34 divided by the mass of the particle is 5.6 times 10 raised to the power minus 23 multiplied by the speed or the velocity of the particle, the moving particle, which is 1.0, which is 1.0 exponential 6, which is 1.0 exponential 6. Our Planck constant 86.63 exponential minus 34, while mass of the particle is 5.6, exponential minus 23 times the speed or the velocity of the moving particle, which is 1.0 times 10 raised to 6. If we use your calculator to perform that, the Broglie wavelength is equals to 1.18 exponential minus 17. 1.18 exponential minus 17. Don't forget the unit, meters. 1.18 exponential minus 17. 1.18 exponential minus 17. That is the Broglie wavelength. So let's quickly go to the next question. That is question 15C. That is question 15C. That is question 15C. And question 15C states that question 15C states that in the planetary model of the atom, state the scientist who proposed the model. In the planetary model of the atom, state the scientist who proposed the model. Don't forget we have different models of the atom. So we have the planetary model. We also have the Bohr model. We have the electron cloud model. But here, what we are concerned about the planetary model. So, who was the scientist that proposed the model? So, the name of the scientist is the scientist that proposed the model was Ernest Rutherford. The scientist that proposed the model was Ernest Rutherford. And what is the sources of the proposed model and the failure of the model? The source of the model is that the man, Rutherford, discovered the source is that he discovered positively charged particle in the nucleus of an atom called proton. And the failure of the proposed model is that he proposed that the atom is unstable. The failure is that the atom, he proposed that the atom is unstable. The atom is unstable. The scientist that proposed the planetary model was Ernest Rutherford. His success was he discovered the positively charged particle in the nucleus of an atom called proton. And its failure, the failure of the model, is that he proposed that the atom is unstable. Now we have question C3. Differentiate between the two types of X-rays. 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 Now, the two types of X-rays we have hard X-rays. We have hard X-rays. We have hard X-rays. Then we also have soft X-rays. Hard X-rays and soft X-rays. The number one difference between the two types of X-rays is that an X-ray is formed or is produced from high potential difference, while some X-ray is produced from low potential difference. The second difference between hard and soft X-ray is that this one has the hard X-ray has high frequency. It has high frequency, or it has longer frequency, while some X-ray has low frequency, or in other words, you can say some X-ray has short frequency. The third point here is that it has X-ray has high penetrating power, high penetrating power, while soft X-ray has low penetrating power. Another point that differentiates hard X-ray and soft X-ray is in terms of their wavelengths. Hard X-ray has longer wavelengths. Hard X-ray has shorter wavelengths, while soft X-ray has longer wavelengths. Hard X-ray has shorter wavelengths, while soft X-ray has longer wavelengths. Now, the more the frequency of the X-ray, the more its energy and the more its penetrating power, which means that the hard X-ray is more penetrating than soft X-ray because it has higher frequency than soft X-ray. 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 I repeat, the difference between hard X-rays and soft X-rays are: one, hard X-ray is produced from high potential difference, while soft X-ray is produced from low potential difference. Hard X-rays has high frequency and soft X-ray has low frequency. Hard X-ray also have high penetrating power, while soft X-ray has low penetrating power. Hard X-ray also have short wavelength, while soft X-ray has longer wavelength. So those are the major differences between the hard X-rays and soft X-rays So let's quickly look at the next question. Let's quickly look at the next question. Let's quickly look at the next question. So the next question states that is question D. Question D. That is 15D. 15D. The following nuclear equation represents two two types of radioactivity. Two types of radioactivity. So the first equation is radium 22688, giving us radon 22286 plus alpha 42 plus E. It is equation 1. While the second one is magnesium Mg 24 and 12 plus N10, giving us sodium 2311 plus P11 plus energy, equation 2. Now, the question under this is that identify each type of reaction. Identify each type of reaction and differentiate briefly between them, Now, this is the last question, that is question 15. The following nuclear equations represent two types of radioactivity. The first one is radium 22688, giving us radon 222, mass number and atomic number 86, giving us alpha particle, which is 4, mass number 4 and atomic number 2 plus energy. And equation 2 is magnesium, atomic mass 24 and atomic number 12 plus neutron 10, giving us sodium 2311 plus P, that's proton 11 plus energy. Now the way to identify each type of reaction and differentiate briefly between them. Now, solution. The first reaction, and the first equation, Roman figure 1. The first equation, which is this, equation 1, represents natural equation 1. Equation 1 represents natural radioactivity. While equation 2 represents artificial radioactivity. The first equation, the first one here represents natural radioactivity in the sense that radium is a radioactive element which can disintegrate on its own to form radon and alpha particle plus energy. But checking the second equation, so it is artificial radioactivity in the sense that magnesium is non-radioactive element, but we made it to be radioactive by bombarding it with a particle of neutron to produce or to disintegrate to the nucleus of sodium and protein. So that's why you say equation 1 is natural radioactivity and equation 2 is artificial radioactivity. So the question still says we should differentiate briefly between them. And what the difference between natural radioactivity and artificial radioactivity? Natural radioactivity It is spontaneous emission of radiation by radioactive elements. Natural radioactivity is the spontaneous emission of radiation by radioactive elements. While artificial radioactivity is the bombardment of non-radioactive elements with the nucleus of protons, neutrons, or alpha particles. While artificial radioactivity is the bombardment of non-radioactive elements with the nucleus of proton, neutron, or alpha particles, and with the release of new particles and energy. So that is the difference between natural and artificial. So in addition, for natural radioactivities to occur, so natural radioactivity always occur with a radioactive element, in which ordinarily they can destinate on their own without any assistance from external but artificial need the bombardment of non-radioactive elements. Ordinarily, magnesium is a stable element, stable nucleus, which cannot on its own disintegrate. But bombarding it with the nucleus of neutron can make the nucleus to change from the nucleus of magnesium to the nucleus of sodium. So this condition or this process is called artificial radioactivity. So this is the end of the solution to our last time mock examination. So inshallah, by the special grace of Almighty Allah, so our next class we see us are dealing with some of the topics that we've already done in the class, and where we think we're having one or two problems or some topics that we think can give us an headache. So we try to be taking them one after the other and we do justice with them. Thanks.